Hi, my name is Benjamin Bacon, and in this video session, I'm going to share with you information about the references that I use to create the video lessons that I taught on designing the inertial propulsion system. The information sources listed in this video are those that I consider to be my primary sources. They contain the most relevant data, facts, and explanations that I use to teach and inform you about the design work that I did within the class of propulsion systems, often called inertial propulsion. Handbook of Astronautical Engineering by Heinz Hermann Kohl. This historical reference book is a complete source of information about everything related to aerospace engineering or rocket science. Though it does not contain the information about modern technology like avionics and computer science, for example, it is still filled with information about the things that shall never change, the logistics, physics, and chemistry that is involved in rocket science. Some of the luminaries and innovators in rocket science, like Oberth, Werner von Braun, etc., were on the board of directors for this book project. It is a good source of information about electric propulsion systems also. Space Commerce, Free Enterprise on the High Frontier by Nathan C. Goldman. Anyone interested in the commercial prospects of space in the 80s and 90s will have been well informed by this book. It contains the initial treaties, agreements, rules, and regulations that were set up to make space commerce possible, not just for nations, but also for business organizations. I read this book, but there are many more newer books around today, some of them by this same author, Nathan C. Goldman. Engineer in Training Reference Manual by Michael R. Lindenberg. This reference manual is standard information about engineering written for engineers or engineers to be. I used it for some of the information about dynamics that is presented in my lessons. It contains excellent explanations and derivations of the rocket equation, for example. It also contains information about systems design and analysis, as well as modeling systems with analogs. This book is a reference for every area of engineering and thus covers every topic that I discussed. One of the best parts of preparing for these lessons was watching the YouTube videos that I discovered that are about the topics that I discussed. These videos show a variety of different approaches to explaining the topics, and you are almost guaranteed to find one that resonates with your way of thinking. The list includes System Dynamics Tutorial 6, Fundamental Analogies between Mechanical and Electrical Systems, System Dynamics and Control, Module 6, Modeling Electrical Systems, Modeling Engineered Systems, Mechanical and Electrical Analogy, Mechanical and Circuit Analogs. Here are more YouTube videos that I watched in preparation for the video lessons. Mechanical and Electrical Analogies, Electrical Mechanical Analogy, Mechanical to Electrical Analogies, Top 22 Facts by Rishika Janaki. And these videos contain excellent information. However, I must warn you that they do not contain any audio, and you have to read the slides, which go by fairly rapidly. However, you can always pause the video to take time to read the information on the screen. Introduction to Circuit Analysis, Water Analogies, which was some fun information that tipped the analogy to other levels, and quite a number of the videos were fun to watch. So this list of video references is not exhaustive of all the videos I watch, but include the ones that may have contributed the most to the content of my lessons. You may use these videos or find your own through the YouTube search engine. My search terms were mechanical to electrical analog, and if you do this, you will get a lot of results to pick from. The videos by Rishika Janaki introduce the concept of power conjugate variables to me, and so I highly recommend them. Finally, I have some websites to share with you. Variable capacitor, Wikipedia, the free encyclopedia, subtopic, differential. Air capacitor, capacitor guide, subtopic, differential variable capacitor. David Hammack, build your own variable capacitors. Air variable capacitors, differential. Surplus Sales of Nebraska, and this was a commercial site where you could actually buy the devices, one of many. Essentials of the SI, base and derived units, NIST, that's National Institute of Standards and Technology. These websites were used by me for information about differential variable capacitors. There was scarce information about the differential type, but they happen to be a subtype of a class of variable capacitor called butterfly variable capacitor. There's enough information available under these two headings to gain an understanding of them. The fundamental units table I used came from the National Institute of Standards and Technology site. Keep in mind that you can always pause a video at any time to get a better look at the information on the pages. That includes these references. Thank you for your time. Have a good day. Oh yes, and don't forget to subscribe to my channel to keep up with this series of lessons and other interesting topics that I may create lessons on in the future.